Artificial intelligence. Just saying it out loud sounds cool, as if we're suddenly living in one of those sci-fi fantasies we've seen and heard about. But ever since ChatGPT kicked the door wide open to AI back in 2022, it feels like AI has flooded the entire planet, invading every single conversation space, from tech boardrooms to doing your homework to even your imaginary AI robotic girlfriend. But instead of robots stalking us on motorcycles or giant machines using us as batteries, AI in the modern day looks something more like this.
Your chicken's looking nice, pal.
Woo! Yo, he stole my chicken!
Got a Christy treasure, can't slow me down. Hot and golden, I'm out at this town. Move, move, Friday, victory.
Well, get back here.
Run, spin, slide, I'm gliding out the door. Fried love in my arms, can't give it up no more. Hey!
Yeah, maybe not the same levels of doom and gloom that Hollywood movies will have you believe, but still, it's impressive in its own way, considering how fast AI has risen. Remember that Will Smith video from just a few years ago? No, not that one. This one. Compare this to what AI looks like today, where it's become increasingly difficult to distinguish it from reality. Which leads you to question, how exactly did we get to this point? How has AI grown? What's the current state of AI? And most importantly, where is AI headed? In order to talk about this, well, we need to understand that AI really breaks down into 7 key levels, at least in terms of where it stands today. Let's explore each one and see ultimately how it leads to where we're headed. Let's start all the way from the beginning at the very first level of AI, which is classical AI. This may come as a bit of a surprise to you, but the origins of AI actually dates all the way back to the 1950s. Yeah, older than you might expect. Do you recognize this guy? In case you have no idea who this is, I just want to bring back the video of Will Smith high-fiving Chris Rock in the face, but with a key adjustment. Come on, if you're in computer science or a developer in any way, you gotta know who this is. It's Alan Turing, a brilliant British mathematician and the unsung hero of World War II, who cracked the German Enigma code. He's the first one who ever proposed a question that would kick off the entire field of AI. Can machines think? Back in 1950, he proposed a Turing test, which challenged computers to hold conversations convincing enough to fool a human thinking it was another person. But the problem? Well, it's the 50s, which means computers had about as much power as a gym bro's legs on a chest day. These systems weren't exactly learning from data or training neural networks. Instead, they were following simple rules created by humans, and that approach became known as classical AI. Classical AI was built using rules and decision trees where humans had to manually tell the computer what to do in every situation. Think of it as the world's largest flowchart full of if-else statements. The huge limitation is that humans had to write every single rule. What we really needed is a way for computers to learn new patterns without being explicitly programmed for every situation. Which leads us to the next level of AI. Introducing machine learning, which is a way for computers to learn patterns without being explicitly programmed for every situation. While classical AI required us to write all the rules manually, machine learning completely turned this idea around by asking, what if computers could learn on their own? Instead of feeding computers thousands of rules, we start feeding them thousands of examples. The algorithm would analyze the data, look for patterns, and gradually improve its predictions over time. The more quality data it saw, the better it got. Think about teaching a kid what a dog looks like. You don't hand them a 500-page rulebook, you simply show them lots of dogs. Eventually they figure it out. Machine learning works in much the same way. And it worked incredibly well. Suddenly computers could recognize handwriting, filter spam emails, predict stock prices, and solve problems that would have been nearly impossible with classical AI. Problem solved, right? Well, not quite.
Nope.
The problem was that although machine learning could learn patterns, it still often needed help from humans. We still had to tell the algorithm what features were important and what data it should focus on. For example, if we wanted a machine to recognize faces, engineers might manually tell it to look for things like eye distance, nose shape, or enough facial fillers to violate the Geneva Convention. And thus, researchers started to wonder, what if the computer could figure out those important features by itself? And this led to the next major breakthrough in AI: neural networks. In order to build something that could learn those features automatically, researchers took inspiration from something that's sitting inside most of you watching right now, the human brain. Your brain is literally made up of billions of neurons that are constantly communicating with one another. When you see, hear, or learn something new, these neurons pass signals, forming connections that help you recognize patterns and make decisions. The more you experience something, the stronger certain connections become. That's literally where neural networks get their design. It's essentially a simplified digital version of the human brain's learning process. It's made up of interconnected neurons that pass information to one another and learn directly from data. These neurons are organized into layers. The first layer receives information, the middle layers look for increasingly complex patterns, and the final layer makes a prediction or a decision. Each neuron performs a tiny calculation and passes the result forward, allowing the network to gradually learn how to solve complex problems. With the help of neural networks, more complicated tasks like facial and speech recognition and image classification became possible. But even with these new abilities, neural networks still struggled with very large and complex datasets. They could spot simple patterns, but when pushed to more difficult tasks like identifying thousands of objects in real-world images, the performance quickly hit a ceiling. However, 3 things happened that changed everything for AI. Number 1, computers became dramatically faster. Number 2, the internet gave us access to unprecedented amounts of data. And number 3, graphics cards suddenly became powerful enough to train much larger neural networks. And yes, the same graphics cards that's powering your fancy new gaming PC right now. For the first time, researchers had enough computing power and data to build neural networks that were far larger and more sophisticated than anything before. And then something remarkable happened. The deeper these networks became, the better they got at recognizing complex patterns hidden within massive amounts of data. This new generation of large, multi-layered neural networks became known as deep learning. Deep learning is essentially neural networks on steroids. Instead of a handful of layers, deep learning models could contain dozens, hundreds, or even thousands of layers working together. Each layer learned a different level of abstraction, allowing the AI to understand increasingly sophisticated information. This was the breakthrough that powered modern image recognition, speech recognition, language translation, self-driving cars, and eventually the AI systems we're all familiar with today. But what if AI could do more than just learn complex tasks? What if instead of just handling complex systems, AI could also generate things on its own? Enter generative AI. Now we're getting a lot closer to where AI is today. Up until this point, AI was mostly focused on understanding the world around it. But generative AI leveled things up with a completely new ability: creation.
Yes! Look what I have created! I have made fire!
Instead of just recognizing patterns, AI could now generate entirely new content based on the patterns it had learned. It can create images, compose music, generate videos, and even write code. Think of it this way. If deep learning was teaching AI how to read, then generative AI is teaching it how to write. The secret behind this is data. Books, websites, articles, code repositories, images, videos, you name it. By learning patterns in an ocean of information, AI could now begin generating brand new content that never existed before. And then in 2022, something huge happened. No, still not talking about that. I'm talking about the explosive growth of ChatGPT, which is still the best known example of generative AI. When OpenAI released this in late 2022, suddenly millions of people can interact with AI using nothing more than plain English. But as impressive as generative AI is, it's still mostly reactive, meaning it still waits for us to tell it what to do. Which raises yet another interesting question. What happens when AI stops waiting for instructions and starts taking action on its own? And that brings us to the most recent level of AI evolution: Agentic AI. If generative AI creates, then Agentic AI acts. Agentic AI brings us as close to human reasoning and action as possible. It can plan, reason, make decisions, use tools, and execute multi-step tasks with minimal human involvement. For example, you can tell it to find you the best flight to Tokyo, compare hotel prices, create an itinerary, book everything within your budget, and send you a summary. Then it goes and actually does it. So how did all of this badassery become possible? One word: connection. AI models started connecting to tools like APIs, databases, browsers, and software systems, which means the scope of its abilities have massively expanded. Instead of just generating content, they can now literally interact with the digital world around them. And this is where we are right now in the world of AI. Companies around the world are racing to build AI agents that can automate customer support, sales outreach, software development, and countless other tasks, spreading excitement and, at the same time, panic to those terrified that AI is going to steal their jobs. But the trend is clear. We're moving from AI that answers questions to AI that completes tasks. And this naturally raises the biggest question of all. What happens when AI can perform virtually any intellectual task a human can do? That brings us to the final level of AI evolution: artificial general intelligence, or AGI for short. Unlike everything we've discussed so far, AGI doesn't fully exist yet. If we do a quick recap, we've seen that classical AI follows rules, machine learning learns patterns, generative AI creates content, and agentic AI takes actions. So what would AGI do? Well, AGI would take all of those abilities and combine them into a single system that can learn, reason, adapt, and perform virtually any intellectual task a human can do. In other words, instead of building an AI that's really good at one thing, we'd be building an AI that's good at everything. While today's AI systems are incredibly powerful, they're still specialized in their own specific ways. Where AGI would make a difference is in its adaptability. It would be able to transfer knowledge from one domain to another, much like humans do. Some people imagine AGI curing diseases, solving climate change, and accelerating scientific discovery by centuries. Others imagine robot uprisings, killer machines, and humanity being turned into pets by AI overlords. Because, let's be honest, it's fun to be dramatic. But the truth? Nobody really knows what happens next. What we do know, however, is that every level of AI we've discussed in this video has moved AI one step closer to becoming AGI. For the first time ever since Alan Turing asked that single provocative question, can machines think, we're beginning to seriously ask a new question: what happens when they can? Now, will AGI arrive in 5 years? 10 years? Well, I don't really know for sure, but what I do know is that understanding AI, truly understanding it, is quickly becoming one of the most valuable things a person can do in 2026 and beyond. This is why I created my newsletter, The Gradient Descent. Once a week, I take a machine learning concept and I break it down in a way that actually makes sense. No complicated lectures, just clear, digestible lessons to make you actually get it. But it goes beyond just reading. Every week you get 3 things: a hands-on collab so you can literally code in Python through guided exercises, weekly practice assessments with fully explained solutions, and visual cheat sheets for every weekly concept with illustrated explanations and Python code snippets. For example, take supervised learning, where all of the machine learning models are organized neatly for you in one diagram, along with the commonly used code. Oh, and when you sign up, you also get a free ebook, Machine Learning Simplified, which is essentially everything you need to understand about machine learning from the ground up. Yours just for joining.
Damn, son.
Click the link below to try it free for 7 days, where you will have everything I mentioned sent directly to your email. And there you have it, the 7 levels of AI, from Alan Turing scribbling ideas in the 50s to machines that can literally write code and plan your vacation. What started as a simple question has snowballed into arguably the most transformative revolution in human history. Faster than the internet, the smartphone, than anything we've ever seen before. And we're living through it all right now in real time. Feel free to comment below on where you think AI is headed. As always, thank you for watching, and I'll see you guys in the next video.